Okay, cool. Okay. Morning, everyone. Let's start with our exam prep, and I think just also I took some of what you were sharing on the WhatsApp group. So if you want to share more in the week, we can do those ones next week. Else, I will pick my own kind of questions that we can go through. But today, basically, we're going through the questions that were shared on the link, and I think one of the big things that was shared was the measures of variation. The formula was shared, and there was questions around how is this calculated. So what I will also do, I'll share my Excel spreadsheet, and I'm nearly building up the spreadsheet for you, that you will have one spreadsheet towards the end of the of all these sessions, that you only need to go into one spreadsheet to seek assistance for some of the measurements. What I will also do is just create one PowerPoint, and I'll convert it into PDF as well, that you have just one PowerPoint nearly with all the formulas, and if there is calculations within the formula, I will share that as well with you. Okay, let's just do the volume as well. Okay, hopefully it is now a bit better. And let's get going. Probably, Christine, I must also just be awake to talk louder. So I am drinking my coffee as we go along. Okay, so basically, what of a measure of variation, and I think one of the things that this formula seems very simple, and the SST, the total sum of squares, is the one that is actually very easy to get your information from. So this one is much easier to get the information from. You have that, you can work out your mean. So SST is a very easy calculation to make. SSR and SSE, so you can decide if you're happy how you calculate SSR, then you can just say your SSE will be the one minus the other one, because this is an equation. And I'll show you in Excel how that is as well. But if you're not so sure you're making the right calculation, you need to do SSE as well. And then in the end, your R square will be that one divided by that one. So if you have calculated this, and if you have calculated this, you actually don't need to calculate that for R square. Okay, so that is also to save time in the exam. Also, maybe you don't need always to complete all the formulas. But let me show you in Excel. So what I did is I took a previous question that we've done in one of the previous study units. And what I've done in that previous study unit is, if you look at this information, and let me just make this bigger as well. But while we make it bigger, you can also see that what I've incorporated here is a few of those. I want to add 1 or 2 extra formulas as well for you. Let's just, okay. So what I've done is, and you will see that I've color coded it the same as the formula. So just to make it easier, this was my SST calculations. I'll go into that calculation now. Let me just zoom a bit more. Okay. So I'll go into the SST calculation now. I just color coded the SSE and SSR, but just as an interesting one, so the SST is a sum of those two. So just, and yes, I will share everything on the WhatsApp group as well. So don't worry, I'll also put it in the Teams chat and elsewhere as well. So no worry at all. The one thing when you calculate this, it's not on a per individual line that the SST is the same as SSR plus SSE. And I think that you must just be careful that you don't, when you start working, you're expecting that as well, because it's only the sum of the squares that are equal to the regression sum of squares plus the error sum of squares. Okay, so it's only at that last level where you do the sums that you get that those two are equal to the SST. Okay, so nowhere during the process that is true. Okay, so the next thing that I wanted to show you, the SST is basically, and we'll go through this slowly as well, that we just get the measures, but it is your Y point minus your mean, and your mean I calculated via your Excel function, but the mean is very simple, the sum of all the Y's divided by N. Okay, so, and that you need to power to 2, and that you need to do for all of them. Okay, so it is for, in this instance, for 5 of the values, and those ones you will then add together to get the sum of SST. Okay, so the SST, yes.
My apologies.
No, please interrupt. This is exam prep, so ask now, and please interrupt me during this chat.
Thanks. Can you show us how to add extra values to the X and Y and take out if we do have one in the exam for extra values, just for those who are not so clued up with Excel maybe?
Yes, so what I will do, actually, I will incorporate another few lines here for you when I share it, because, okay, so the easiest for me to add is, so if you, so let's say I insert, but I will, and I think what is important is how I've created, so you must make sure when you add that you actually increase then your scope of all your calculations. So I think this, let's do it for now, that it is, so this one I actually did foresee before. All the others I think I have had, but it was fine if I just want to check. Yes. So the best now to add is to say, and let's make it another color. If you want to add more, add at row 7, because then automatically the formulas will be correct as well. So whenever you now need to add or want to add to row 7, and your formulas will automatically adjust correctly because it looks at that whole picture. Is that fine, Christine?
Yes, thank you.
Cool. So I'm just for now gonna hide this, but when I share, it will be open again, so that you can just see all the other calculations as well. Okay, so the SST is, let's call it the easier one to calculate. So that is just normal, the x value minus the mean, and you square, you take that to the power of 2, and you sum it. Now we get to the SSR, and you will see in the SSR formula that we have a y hat, and then we have the mean. So the mean is fine. We don't have an issue with the mean. The mean we have previously worked out. 100% we know where to get that. The SS hat is where the more difficulty come in. So let me just write here. So you would remember from that your SS hat is basically the prediction of your y value. So you have your slope, let's just do that. You have your x value, and you have your intercept. Okay, so this is now where I still need to add, because when I worked this out, I forgot that if you don't have this information, we need to use, so luckily they gave us the data, and I assume in all your study unit work, 11 work as well, that they actually gave you the data. But I will just make sure that NET is incorporated. Yes, Christina.
Adrian, sorry to interrupt. This is actually where my confusion, I managed to figure out the question in the assignment, but my concern was that in the workbook and in the study guide, they give you X and Y, and they give you a formula, and everything works perfectly when you have X and Y values. However, in the assessment, they gave you two Y values. They gave you the observed Y value and then the predicted Y value. And if you substitute that as X and Y and you use the formulas provided in the books, you don't get the answers they provided as options. But if you use the screenshot you have on the right there with under the measures of variation with the Y observed, if you use those formulas, then you got to their answers. So for me, it was just a bit confusing that they would give you a question that they don't cover in the books. Luckily, I went through some other resources, but I was just thinking of those that didn't have those options available to them. So if you have X and Y and you follow the formulas in the book, it works perfectly. But if you only have Y values, then you need to use the other formulas, to put it that way. The formulas don't match up, if that makes sense.
Okay. You don't have that as if you can share that question with me, that would be great.
Okay,
If you still have it somewhere.
I'll quickly post it in the chat, but please continue. I don't want to steal too much of your time.
No. I think that is because I just want to check if that's not a chi-square kind of question, that you can still use the same type of formulas to get to the answer, but it's a bit different. I just want to see if it is regression or if it is
chi-square. Quickly go get my question to post in the
and you don't
chat.
you don't need to do it now. You can do it later and we can cover it next week as well. It's not the issue that we need to do it now.
No, I have it on hand.
Okay, cool.
I had
Okay.
the same problem in the assignment as well. When I calculated everything according to the values I had, it didn't match up to any of the answers, no matter how many times I tried different formulas.
So, and I suspect the reason for that was that in the assignment they gave you two y values, whereas all of our examples in the books dealt with x and y values. That's the only like difference I could pick up that would potentially cause this issue. But it was a nasty surprise, I'm not gonna lie.
Okay, this is an interesting one because it's nearly... Okay. Okay, let me quickly see if I can copy that and actually...
I can give you the values, or I don't think I have these specific values, but I have other variations of them that I have editable that I could give to you.
Don't worry, we'll cover this now as well. Don't worry. Okay, cool.
I'm quickly going to find the formulas provided in the workbook, then I'll post that on the chat too, just for context.
Yes, because I think this is actually maybe a easier one than we think. So I'll just add it here as well. Then I'll get to that now. Rory, you can, if we get to the questions today, you can add it in the post. Otherwise, you can add it into WhatsApp as well. No problem at all. And luckily we've got some time to cover a lot of these things in, well, a lot of time, nearly a month. So that hopefully we yeah. Okay, so I'll get to that other one now because that looks like a nasty, interesting question. So SST we fine with. SSR we need to work with this formula. So what I've done is I've built that formula in the equation, but with this formula you needed also to work out the slope and the intercept. And that I have done with Excel. So what I want to add for you here, and I'll do it in this space. I just want to use the formulas also that they give you if they don't give you the data. So I will build that in this morning for you or during the day, that you just have a full picture if they basically give you this set of data, the sum of x, y, and they don't give you the data. So I just realized last night that actually that's one part missing. But what I've done is, so what I've said is, and if we look at the formula, it is your y value that they've given you minus, and let's first do the SSR. It's your regression value, so that predicted value minus the mean. So I've built into the formula for you that value, so that it is calculated. So just want to make sure what happened now.
Gene,
Yes.
the SSR, the y hat, is it the total of all the y hats minus the mean?
No, so it is the y hat that I've calculated. So here is my formula for that. So it's the y hat minus the mean of the first one to the power of 2 plus the next one, plus the next one, plus the next one, plus the next one. So you need to actually calculate them separately and then only add them. Does that make sense? Did I now answer you correctly?
I'm actually referring to, or maybe I'm just misunderstanding. If they ask you, if they give you the X and the Y values and they ask you to calculate only the SSR,
Yes.
can you just maybe show us how to do that on Excel and maybe manually as well?
Okay, see, so if you, so let me do that for, I just want to copy that back into, okay, so let's just, so it is the hat minus, okay, so that is what we need to do. So for the hat, and I'm just going to do it here, that mx plus c, and that is how I have then also calculated in Excel. So, okay, let me quickly see. Okay, so it is, m is your slope, it's that 3.54. Plus the x, or sorry, multiply the x with, the things have changed again. Okay, so I'm just multiply 4, I don't know where the, I must check how quickly these things have changed. So that is looking at that part, plus the slope, which is minus 3.2. Okay, so that would be your y hat. And let's just quickly calculate that. 3.54 times 4 minus 3.2. 10,96, and let's hope that is what I got in Excel as well, 10,93. So now you can also see when you use, because that is probably a different number, that you're going to get close to that. So again, depending on what we round off, but so that is your y hat. Then you need to say minus, and that was your mean, 24.4, and that to the power of 2. Which is 180.63 or 0.64. Okay, let's now just see where, okay, what did I do here? That is now just a formula. I probably changed. Okay, I just now need to, I changed that to show the formula. I just need to change it back. Where was that? Okay, but that answer is what we've calculated. But that now is that 180 is only for that line. So now you need to do the same for that, and then add all of them together. Okay, so then you need to add all of them together to get the 462. Okay, does that answer a question nearly on how you would have done it manually?
Yes, thank you.
Okay, so what I've done is I've created in here your y hat for you so that it already says that slope times the x plus the intercept. So you will now see if you change that to 12 to 2 and 22. See, I just need to see what I've done there, but then automatically the values change, and you can see all the other things change as well. Okay, I just need to see what I've done with that part of the spreadsheet. Okay, so I will add the components still if they only give you this, but I haven't seen anywhere yet that they only give you that without the data. But I'll just make sure. One never knows, so that if you get any of this, you can basically just change it in the Excel and it still calculates the values for you. Okay, there it is. It is correct now. Okay, so are you guys okay with how we've calculated this? And I'll definitely share the spreadsheet. That is definitely for you to use. Okay, so let's do this one. I was thinking this is maybe a catch question. So it is definitely regression. It is not chi-square. And just check if I've done all the numbers correct.
Jean, I've added the predicted values for you in the chat if you want to copy and paste.
Awesome. Works, and hopefully Excel picks it up as numbers. We'll see now. Awesome. Okay, so basically what we've done here is, that was quite interesting, but that is okay. So that's what they've given us. They told us that is, and let's just make this again a bit bigger. Cool. Okay, so they've given us that information. They told us that is the reading, the observed numbers, and that is the predicted number. So let's just go back, and they ask us to work out SSE. They will ask us to work out SSE.
That is the part that varied. Some would have gotten SST, some would have gotten SS score. But the values also shuffled. So okay. That was my observation.
Okay, so that is interesting. Okay, so and that is how it's going to be in the exam as well. So let's be honest, that is how it's going to be in the exam. It's normally not going to be a different question. It is just going to be a different something different that you need to calculate with the same information. I think in the end there is like 3 or 4 different exam papers that will be done that day. Okay, so let's, out of that, let's do all of them so that we have it as well for you. And I think this was the one that, so that was observed and that was predicted. Okay, see, so they already give you the predicted value. So you don't need to work out the predicted value. So my understanding would have been that it is, and let's just get to the, those. I just want to see those options. Because I'm nearly, they give us, okay, so they give us all the information. So if we needed to work out, and for this one we needed to work out the SSE. So if we needed to work out SST, I would have said, okay, it is my observed minus the mean. So we don't have a mean yet. So we will work out the mean there. Yeah. Okay, so you can also see this as y and as y hat. Just like that. Okay, and now let's hope when we calculate this that we do get the same answers. Okay, so SSR would have been your observed value, or sorry, your predicted value, minus the mean. Let's do that. And now for the golden one, let's just say it is your observed value minus your hat Oh, okay, so it's not the same. So let's quickly see what is happening and if SST, SSR, so those two need to be, let's just check. It is that one minus that one minus predicted that, sorry. that needs to move as we go along. Okay, so there is your correct answer. And those two will also be the same as that. Okay, so again here you can, I'll share this as well, that if you have this in the exam, you can just use this one. So the catch with this one was they actually have given you your observed and your predicted. So they've worked out the y hat already that we needed to work out. So they've actually worked it out for you. So in a sense, it was easier, but it is very confusing because then you look for different formulas because you want to see the two y's nearly.
Yes, so that's the part that was concerning to me, was the fact that all the examples provided that I could see in the provided materials were X and Y values. And obviously you can't substitute one of these Y's as an X. You won't get the same values.
Yes, so if, and that is maybe also, so they can, if it was not the predicted value of Y, they can give you two values that they call Y1 and Y2. And that you can treat as X and Y. But because it was the predicted value of the Y, you need to handle it differently. Okay, yes. So they can nearly tell you that you have two variables, so one is Y1, the other one is Y2. Then you can treat it as X and Y, but because it was the predicted of the observed, you need to treat it a bit differently. But this now, again, I think will come in handy for you if you need to work it out in the exam. Does everyone happy with this?
Yes, thank you.
Cool. I'm just checking also your calculations on Excel. That's perfect. And I just want to see. So we got the same answers on all three of them. Yeah. Cool. Okay, so let's go to next one that we now have handled. Okay, so let's see what was also on the group. So this now, you would see there was hypothesis. I just want to check. So this was probably your assignment 4, I think. But let's look at some of the problems from that. Okay, so this is an interesting one that, oh, there's the eraser. Okay, so at least I see now they have changed it to look like that. At least I've now found it. Okay, so in a sample of 56, the sample mean is that. Also known that the population standard deviation is 16. Okay, so if we know what the population standard deviation is, we work with a Z. Okay, so that's nearly the first thing that I look at. You are required to use the information to test the following hypothesis. So that is your hypothesis. Which of the following statements about this test is incorrect?
Jean?
Yes.
I think in the assignment, the
Yes.
bottom H1, the sign was turned around, if I'm not mistaken.
Yes,
Oh,
I also remember a correction that was like made about one of these questions where they said the signs had to change.
okay. Can I see? So if because then else that one would be automatically your wrong one. If I look at this set of questions. Okay, so was it that it was maybe changed to that?
I think it was just the H1 sign that
Oh,
changed.
okay, that would be interesting if just H1 is changed.
Jean, I posted the changes or the corrections to assignment 4 that they posted before you start the assessment. So it's just as the alternative hypothesis, like Christine said, I think it was Christine, that needs to flip around.
Okay, so both of them. Okay, so that and that needs to. Okay, so it should be H0 is. Okay, so it should be this. Okay, cool. So that is, thank you. That is not part of it. Okay, cool. So then we work with this information. Okay, let's quickly see what else there they talk about for 1%. Okay, so we get to that now. So first, okay, so that one then will be correct. They nearly give it away in that. Oh no, yeah, they are giving it away in that question set as well, because they say change vanilla an alternative hypothesis to this, i.e. you are given an upper tails test and not a lower tail test. So which of following statements is incorrect? An upper tail test is applicable, so that is actually incorrect. So yeah, otherwise I would have marked that incorrect from the start. So let's just then look. So population standard deviation is still the same, or is nearly known. So I would have used this to work out my Z value. Okay, let me check what.
A is correct.
Yeah, because let's just, I assume sample mean, so let's do, it looks like it's going to be correct. You will seldom have the mistake in that one. That is just, so let's just quickly work that out. 86 minus 80 will give you 6 above the line. 16 divided by 6 will give you 2.66 below the line. So basically 6 divided by that gives you 2.25. So that is correct. If you've used a T, you would have gotten that one wrong. Let me also see this. So do you type this in, or are you using Excel as the back office for the hypothesis testing? Or just formulas, your own formulas?
So yeah, it's in Excel, but I follow the formulas as provided in the book.
Okay.
Basically just doing it in Excel, like a
Okay,
calculator.
cool. Okay, awesome. So when we give you different samples, it automatically changes at the bottom as well. Awesome. If you can share your Excel, then I can just include it into my spreadsheet as well. That would be awesome.
I'll happily share it. It's just very like all over the place.
No, it's fine. I'll pull some of it together. Don't worry. And then I'll add it to one sheet for everyone. So don't worry if you bombard me with with 10 of those or 20 of those. Just I'll collate it for the guys.
Well do.
Thanks, because yeah, that makes it so. Again, if you use Excel, or if you're more comfortable in a calculator, or if you actually want to use online tools that you can put in the variables or the numbers to that, it is really until there's no monitoring of how you write the exam, it's basically you and tools. So it's just not you and somebody else that can do it, but you can use books, you can use online tools, you can use different calculators, you name it. So please do that. Okay, so I just want to draw normally how I would just look at this as well. So your T stat is somewhere there, 2.25. At a 1% level of significance, the rule is to reject the null hypothesis if a p-value is greater than or equal to 0.01. What's your answer to that?
HO is rejected when the p-value is less than the significance level.
Okay, so is this the wrong one?
Yeah, I think so, because they say greater than.
So let's just check that and the other one. Okay, so let's do that. The p-value is 0.0122. How do we go and look for that p-value?
In the Z table.
Okay, in the Z table. And where are we going to look for that in the Z table?
Next to negative 2.25.
Okay, so let me first, I want to open that Z table that we just I'll share the table now. When I get to it, it's somewhere in study guide. Oh, yeah, study
Page
unit
120.
Cool. I am there now. Okay. Okay, so remember 0.0122. Okay. So I'm not going to look for it in the positive numbers. If I want to, I need to say 1 minus what was it, 0,0122. So I can do that, and it would be looking for where Z is 0,9878, 9878. So it would be 2.2. Okay, this is weird. 2.25. Okay, or I can look at it the 0,01, and there it will be then, let me just quickly get it again, the number 0,0122, 0,122, 0,122, so minus 2.25. But remember, I'm working on that side, so it is just a positive 2.25. Okay, this is weird. So the two are the same.
No, if you look next to 2.25 under the Z table, you do get that 0.0122 value.
Yes, but
So on the right, you find two.
But your T stat is the same as your level of significance, or your T stat is the same as your calculated stat.
I'm confused now.
Okay, so the P value that we've worked out, sorry. Yes, sorry. I was now, see, it's too early. That is your 0,0122.
Yes.
Which is what we've calculated there. So if we've looked at that value in your Z table, we would have gotten that. So because that is linked to that. Sorry, I was now looking at the 1% and not, I was looking at question C and not actually understanding what I was doing. So we still need to get the 1% to get your critical value. Okay, and for 1%, we can basically use the confidence interval estimate study unit 8 table, where a 1% one tail, you must just see if I'm correct on this one, is 2.33. Okay, so it's slightly more. Okay, so that is why if the T-stat that we calculated is less than the critical, we do not reject. So does this tell you that this is wrong? So you accept the null hypothesis. Let's just read that again. At the 1% level of significance, null hypothesis is not rejected. Not rejected means the same as accept. Okay, so that should be correct, and then that is the wrong one. Okay. Are you happy with that?
Hi, Jean.
Hi, happy with that?
I'm a bit confused because 2.33 is in the rejection area, and now we are accepting it. How is that?
So you're rejecting. Let me quickly. So if your test value, and let's write that a bit bigger. Let's just, come on, what is that? Eraser. That's not cool. I just want to write it over again. Okay. So let's just do it a bit clearer as well. And we have a bit more space. Okay, so let's look at, so if your T-stat okay, so remember our T-stat was 2.25. Our critical value was 2.32. Okay, so let's just add another 1 year critical so that we can just check all of the scenarios. Okay, so if my critical value is smaller than the T-stat, that part I reject, that I accept. Okay, but if my critical value is bigger like we have now, so this is our actual, is that the critical is bigger than the T. We will accept H0. I think the important thing to nearly what we need to get to is all of the, so accept H0 is the same as okay, so let's get that wording correct, because I think there's a lot of the, okay, so null hypothesis is not rejected. So that is the same as accepting. Then the other one we could have included in that same one is reject H1. And I think that is, so we just need to every time make sure what wording they use in the exam as well. And I think that is very critical. So in the exam, they like to, and I don't know even if there was a question like that in the assignment, but I have seen in previous exams, and I'll go and check if I can find that question where they only had given you the hypothesis with a critical value and with the t-stat, and then they give you 4 or 5 options of reject H0, reject H1, do not reject this one, accept this one, where they basically, with a play of words in one question, ask you the same thing. But I think it's just important how we look at it, and which ones we accept and reject and not reject. So a lot of play in the words, and you will see it with a lot of the hypothesis testing, the rejection and acceptance of different. Oh, so it was actually one in this one. Okay, so I'll see how many of these I can add to, and maybe it is in, I think it is actually in this one. We'll get to, else I will add it. There it is. Okay. So it's just to nearly keep the focus on what they are asked, what question they are nearly asking every time.
I don't know if this will work for anyone else, but what works for me is to write out the decision rule in front of me so that every time I compare, this is what they're saying, this is what I need to look for. And then I eliminate the ones that don't fit based on that, because I get confused very easily.
Yeah, what I've done, and I'll just make it clearer in the notes, is I've created something for me as well. So I'll just share that with a graph that you can see that clearly when, because it is confusing, and then to that confusion they add the different, just changing the question a bit by including that not, and then also by asking incorrect, so it's nearly, you sometimes overthink some of the things as well. But I'll share how I've done my decision as well. But please share yours as well. I think the more we can add to the pack that I'll share later on, the better, because people just look at it differently. So yeah, the more we can add, the better. Okay, the next one, let's quickly. So this was more. Let's do a different color. The emotional intelligence quotient score of a grade 8 class is normally distributed with a mean and a standard deviation of that. Random sample, I think that was nearly all samples was 36 in this this assignment. Okay, how would you have done this? Z or T? And is there an easy way to look at it?
Jean, can we do this one in detail? Because this question completely threw me off board. I did not know how to do this one.
Okay. Okay, so standard deviation is known. Anybody else happy that standard deviation is known?
But it's the sample standard deviation.
Okay. Okay. And I think that's the catch. Okay, so they don't tell us it's a population standard deviation. Okay, so that can be nearly the difference between a 78 or a 76 score, or even the other twos. Okay, we don't know if this is the population. Okay, so then we need to use T. Are you happy? Will that make it, and will that make a big difference? Okay, so what they've done here is, remember when you do this calculation, and first I'm just going to show you the Z. You would have said the Z is X minus that. We would have done something like this. And this Christine, is just to, if it comes at any other way to you, this is nearly, so we would have done that to get you a Z, so that you can go to the table to get your probability. Okay, so now they give us the probability. So they give us that, and they want us to work back to that original question nearly. But now we need to not work with the Z, we need to work with the T. So is there a difference in how we calculate the Z and how we calculate the T? So that is, or is the only difference that you look at a different probability table? Okay, so that is nearly the thing that we need to make sure of. So we've got a random sample of 36. And this is actually quite a difficult one. So random sample of 36, here degrees of freedom will be 35. So how do we this would be study unit. This is not hypothesis testing. This would probably be study unit 7, I think. 7 or 8. I don't think it goes back to 6. 7 or 8, I think, because this is definitely not hypothesis testing. It is not chi-square. It is not. I think this is more. It's not confidence intervals. So between 6 and 7. Okay, now everybody is quiet. So what would we do with this information that we have? Yes, Christine.
Sorry, I just want to know, will they be providing us feedback on the other assignments as well? Not just under your grade book, but the ones like they did in assignment 1 and 2, showing the calculations as to how they got to the answers.
They should. I will ask the lecturer just that he does it. So feedback for rest, like in assignment 1 and 2.
And then as well, you say we are going to get a guideline as to what
Yes.
to concentrate on in each chapter.
Yes, yes. The guidelines and then the tables, it will all be packaged into one PDF, and the formulas. So I'll just ask that also for him to just see how quickly he can distribute that. But that will, yeah, that will all be given. So let's just, yeah, with only a month and a bit, I'll ask him to do that as soon as he can. I think the feedback one is more important. So let me, I'll send him a WhatsApp later today. Okay, so with this one, what would you guys do? Did any of you do it in the, or did you guess?
I think my brain formatted this.
See, I'm now, and nearly coming back to the COSI, I can't see how we can do this with a t value. Unless, so what I would have done is I would have done the same as, and if I pronounce it wrong, because he's sorry for that, but I would have nearly done the same that you did. I would have looked at the Z table where that value is. So I would have gone to say, and we know it's bigger, but I want to use the negative table of, what was it, 0.082, 0.08, what was it, 2208, 0822. So I would have used minus 1.39. To see 08, it was 08, oh, 0082, 0082, sure. Zero zero 82. Okay, so I would have used the minus 2.39, would have then used 2.39. Let's just, okay, so is the minus 2.4 closer? Ah, how did I miss that one? Awesome. Minus 2.4. Thank you. So because it's on the bigger side, it is 2.4. So then I would have said, okay, I know what my Z is. So Z is 2.4. I don't know what my X is. I know what that is. Standard deviation, sample, standard deviation. So let's just, standard deviation is 20. Sample is going to be square root of 36. That will give you 6. It's x minus 80 divided by 20 divided by 6. Ooh, 3.33. Continuously, now I'm worried about rounding off, but let's just take that. So when I say from that point, 2.4 times 3.33333 is equal to x minus 80. will be the 2.4 times the 3.333, which is 8, plus the 80 that comes over. So x will be 88. Okay, so now the question is, did anybody else get that as well? I would have, as in previous times, I don't know how many times I said it, I always guess C in the exam if I don't know the answer. So that is just my philosophy. If I don't know the answer, I guess option C. But let me just quickly see if it was 80 minus, and see that is at least correct. We couldn't, if that went over to that side, we would have got it maybe 72. Okay, so this is interesting because my original thought also was that I don't know if it's a Z or a T, but I think the one thing that we also need to look, and that is if you look at that normally distributed, that also implies that the standard deviation is a population standard deviation. So I think that for me is also something that we just need to, and I'll get those rules and show that as well. But yeah, this was an interesting one that we needed to handle from the opposite side nearly, because you guys are used to say we need to look for we need to get the probability. So to get the probability, we get the Z. We get the Z, we go to the table, we've got the probability. Here they give you the probability and you need to work back towards that X value. Yes.
Jean, this looks like it was from study unit 7, so that would be Z value.
Okay, 7. Cool. Okay. Yes,
and I think I would have done a plug and play maneuver with each of the provided X values to see if I can get to that probability. See,
and that is, he is not on the group anymore, but that was Muhammad from 4 or 5 years ago from one of my groups that said that is his Scully method. Is basically you look at the answer and he plugs it back into the original, and whichever one is the one that he chooses. And I think that is, he said he does it with a lot of these questions. If he knows there's something that with some of these ones, it's very difficult, but with the ones that nearly have one answer, he called it his Scully method, but he looks at it. So that is definitely another way to do it.
Jean?
Yes.
There where you have the X minus the 80 and then the 3 underneath. Where do you go from that to get the 2.4 times the 3.33?
Okay, cool. I'm going to write it here at the top. So what I should have done is to make it, I should have followed the maths rules. So this is what you should have seen. So basically what I do is the maths rules that tell me to get rid of that, I multiply both sides with 3.33. So here I would have said 2.4 times 3.33. I would have done it on this side as well, which will make it that those two cancel out so that I only sit with x minus 80. So then that will be 8. If I multiply that out, this is x minus 80. And then I take that over to that side. So the minus becomes a plus. So it's 80 plus 8 is equal to x. Okay, happy with that explanation?
Yes, thank you.
Cool. Okay, so let's see if we can do another one or two. This looks also interesting. Let me just do the view a bit smaller again, that we can. I just wanted to see. Okay, the emotional intelligence of high school learner, deviation, standard. Oh. Let me just see if there was. Where's the other? Okay, that was given. So is there enough information in here? Or was there some info cut off? Emotional intelligence score of high school learners. Oh, feels
I think
to me.
this was also one of those math questions where you had to work the formula backwards.
Yeah, but do we have enough? I'm just worried that I don't see enough, and that some of the questions was cut off because just to have a standard deviation. So
You
if
need the
yeah, so let's just go back quick. So I need for these questions, you need at least four of those. So you can't say if there's not 4 points, you can't work. So they can give you the Z. So, and that is where we also can get the probability that can give you the Z, but you need, so you probably had that as the X. So if that is when the one that we're going to calculate, we have that. Okay, sorry, so that was 110 learners with scores. Okay, so this is the proportion one. Is it? See, so I don't see the rest of the information. So it can be that we're working here with a Z, with a mean and the standard deviation. It can be that we work with proportion if they give me that, but we need more information for this one. So let's see, Rory, what was in your one? Okay, so I think the 80 would have been.
Mine was the same as Rory's, or similar.
Normally distribution. So you have a mean of 80. Okay, so what would you guys have done with that? So let's copy this one in.
I feel like I have so many shortcuts to things. I don't know any of the things we did the whole year.
So let's. Emotional intelligence, so let's just do it. And let's take that part out. Oh, come on. Okay. Emotions high school normally distributed with mean of 80, standard deviation of 20. So let's go back to draw. My computer is getting very slow at the moment. Please don't do that. Okay, so we've got the mean of 80. Standard deviation of 20. We've got okay, so let's just quickly see. Huh, this is interesting.
I think there was a similar question to this, and if I remember correctly, in either the workbook or the study guide, it was like a very odd question, and I think it didn't have an answer. We had to go Googling.
Because I'm just checking if that is my formula I can work with. What is that gonna tell me? And the other one is to check the proportion one. It feels to me proportion, but but that doesn't tell me anything about okay, I need to go and check this one a bit out. And when you can, but when oh, this is an interesting one. I'll need to think about this one a bit. Because it nearly feels to me that we're not working with this, but we're working with the proportions. I need to, this is an interesting one. This is quite, I would have, if there were 1,979 learners with scores higher, she said it's all about the scores here. But we want to get to the students. You say, is that information that they give us there useless information? And do we only work with that in there? Okay, I'll go in and play with this one a bit.
Why don't we Why don't we start by looking for Z that is greater than 97?
Okay, so see, so that Z greater than 97 would have been,
That would have been
oh, so do you want to work this out
yeah, something like that.
and see what the Z value is?
Mm.
Because we would assume that 197 is then the N. That is what I would have assumed if I worked with.
Because if we found a Z that is greater than 98, it is easier for us now to find the probability of those ones who are less than 97. Then we can work out the mathematical way now to find
Okay.
the total number of students.
Okay. I'm gonna park this one and I'm gonna look at how we can do this. That I know, don't take you on a route and then I confuse you and then I need to look at it again.
See, that looks similar to what I did. I also used that formula of z equals x minus mu divided by standard deviation to get a z value. And I used x as the value they wanted greater as. So in this case, it would have been 97. So then I would find the probability on the z table. And then this is the part that confused the living daylights out of me. But they took the n that they provided, and then they times it by that probability you found, which gave you a number. And then they kind of worked it backwards, where they took that number that you get and you divide it by the probability, and then eventually you got a number equals to n that they're looking for. I have no idea if any of this makes sense, but it got me to my answer. I posted mine on the chat, the way I did it. So I didn't create an Excel spreadsheet for this one. If I did, then I would probably have just once again updated the values and then took it from there.
Okay, let me see. Oh my soul, did they do that?
Yes, they broke us.
Oh my hat. Okay. Yo. Okay, this. Okay, so. Sure. Okay, that is.
It's like they reverse engineered the whole thing.
Yo.
Okay. On the group, there's someone who also posted something like that on question number 5. If you look in the group media, there is some writing in pen about question number 5 that is similar exactly as this one, and they worked it out from that point. When it came in the assignment, something like this, I got it right because I followed that on the group.
Okay. Okay, if somebody can post that again, I've lost all my group chat.
Do you perhaps mean question 6?
It was probably
instead of
question
5?
6.
I'll post question 6 just now.
Okay.
But it also had this, I want to say, reverse mathematical maneuvers, for lack of a better term.
Yeah, but let me post it, please. When
I've just reposted that item. It's just a workout, no question involved. But if you look at the workout, it is the same as what we have there.
Cool. Then I will update a bit of this so that we can get to the how so that I can explain what we are actually doing as well. So that if I change one thing for the exam, then at least you know also what to do, because this is this is quite different to other ones. And this is, if you think about how much time you have in the exam, you don't have time to see this one. I'm more happy with, because it takes your formula and things like that. But the other one, where you need to look at area and things like that, is not something that you guys would have done frequently. So the one that you just posted, Christina, that one, this one is nearly what we've done in
the previous question.
In the previous question, which for me is fine to ask, because it's just but
plug and play.
But this one is way different. Yeah. Okay. I'll check some of these out and post it. You can post it on the WhatsApp group as well. I'll just add to this. So what I will do, and this nearly will be better, is I will just go on with this one presentation and just add more questions to it, that we don't have more than one exam prep kind of presentation as well. I'll just add all of it to this one, and we just continue with this. Okay, so that was it for today. What I'll do...
I've also sent you the question, Jean.
Cool, thank you. Thank you. So what
the same solution.
Awesome. Thank you very much. What I'll do, I think the Saturdays work better for most people than in the week. It's better for me as well. But I'll increase our time a bit. So maybe I make it 8 to 10, but that we just get some more hours in. So I'll probably change it for next Saturday to do it from 8 to 10, that we get a 2-hour session in. And then you have time if there's other sessions that you need to go to as well.
Jean?
Yes.
How are we going to do the exam prep? Are we going to do each session? It's going to be a different unit, or?
So I was thinking that I throw, as we get these types of questions, I just add it and we discuss, unless you want to say to me, let's look at study unit 1 and 2 and 3 next week, or something like that. I'm open to what works for you guys. If you prep for that, then we probably need more structure. So I'm open to what you guys want us, how we need to do it.
If I can suggest, maybe if we do it like either the assignments, like assignment 1, chapter 1, 2, and 3, and maybe you have the whole week to prepare for if there's any questions you need to be answered, or you have any concern with, and then we can do it like that maybe, or individual units, but having enough time to prep for it as well then.
Yeah, so maybe much more structured. So I like that idea that we say for next week, for next Saturday, we cover study units 1 to 4. And you can bombard me this week with questions on it. I'll add it to and I'll prep for that. And if there's no questions, I will include some that I had from previous exam papers and trial papers and things like that.
Jean, in the exam paper, in past exams, did they tell you, like, did they sectionalize each of the,
Yes. Yes.
telling this is that, like, let's say
So
mean and standard deviation, and this is measures of variables or whatever. Did
no,
they explicitly tell you what you're
no.
doing, or do you need to recognize based on the question?
You need to recognize, but it was in order. So the first two questions was study unit 1, second two questions was study unit 2. So it was in order from question 1 to 25. You basically
Okay.
had 2 questions per study unit, and it was from the beginning to the end. So they didn't have it that
Mixing.
they didn't mix it at all. Previous papers online was also, because you would now have seen the instability of a system, was that they would have normally split the paper up in 2 sections. But I think this year they're going to have it as one paper, but they give you extra time nearly for loading the paper. And so it's not that at 8 o'clock you start and you can only then get access to the paper and load and things like that. And so what they did in previous exams was, you nearly, if it was supposed to be an hour, you got an hour and 15 minutes. So that bit of extra time to if there is slow processing or loading of a paper and things like that. And I think that is why when the exam mock paper is out, that is why it's so important when that is out to do it, because it gives you an understanding of how quickly the time goes by when you write it, but also that on the back end, the lecturers can check, okay, but it actually was only possible to do 20 questions or 21 questions. So the first time that the paper was written as online, it was actually downscaled to 22 questions. So just to see how quickly people can move through the questions and the screens, and if there is anything in the back end. But on that day as well, what will happen is, obviously the WhatsApp chat group will be muted or closed, that we don't share questions, but I will be available, that you can send me a direct message, and the lecturer is also available, so that if there's anything going wrong or you can't find the paper, you can communicate with me and the lecturer. So that is, and he can go into the system also to see if something went wrong in your paper. So it's not that there's no communication or anything, and so at least on the lecturer's side, he can also see what's happening. Okay. So hopefully that gives a bit more for you guys, but we'll get closer to the time. We'll share more information as well.
Thank you.
Cool. Have a great Saturday. So for next Saturday, we will basically do